We are going to discuss the position versus time diagram now. The position versus time diagram is one of the most important diagrams in the chapter of kinematics, and it is useful in finding the speed of the object, especially the instantaneous speed, and then finally you can find out the average speed. So what we have in this diagram is our y-axis is the distance traveled, while our x-axis is time, which is in minutes. Now you have two different trains. I mean, it can be trains, it can be cars, but over here, let's say P and Q are two different trains who start at different timings and reach 100 kilometers at a different time. So what we are going to do is find out different information about it, like the instantaneous speed of P and Q in a certain time interval, and finally the final average velocity of both. Anyway, let's take for P for example and Q for example. What does the slope, I mean, whenever you deal with these kinematic diagrams, the slope always has an important meaning. It's either the slope or the area under the curve. But when you're dealing with distance versus time, it's usually the slope which is more important. Now, we know that the standard formula for speed gives us distance, the speed is equal to distance over time. So we are going to use this formula, use this formula and find out the speed of P and Q in the time they are actually moving. As you can see, so let's take Q for example. From time equal to 0 to time equal to 80, it's traveling a distance of 100 kilometers, and then it stays at 100 kilometers further. What it means, like, it's been traveling at some velocity for in the time intervals of 0 to 80, and after that it is stationary. The same for P. It goes from 10 to 70 from the the time interval of 10 to 70, it is traveling 100 kilometers, and after that it remains stationary. So let's see what we can find out from this diagram. Now people might ask us, so what can you say about the speed of P and Q just by looking at the diagram? Now if you look at the slope, the blue slope, and the Q which is the orange slope, if you look at the slope of these two of the two plots, you'll see that the P has a much steeper slope than Q. Now we do know that velocity or speed is given of distance over time. So for a particular interval of distance, particular interval of time, this is basically the slope of the graph. So speed is basically given by the slope of the graph. So the steeper your slope is, the more higher speed you have or higher velocity you have. So looking at this instantaneously, you can say that the P has a way higher speed than Q. I mean, it may not be way higher, but you can look at the slope and say that P rises much faster than Q in a particular time interval. Now what we're going to do is actually use this diagram to find the speed. Okay, so if you look at this, what is the slope? I mean, slope is just difference. I mean, if you're not familiar with slope is just given by the delta y, which is the change in the y-axis over some change in the x-axis. So now in the case of, I mean, let me just keep it over here. In the case of P, the slope is, I mean, if you look at P, I mean, my y-axis, change of y-axis is this. It's the same for P and Q. I mean, it's 100 kilometers. So let's just leave it at 100 kilometers. While for P, my change in the x-axis is given by 70 minus 10. This is the change, right? I mean, you can write this 100 minus 0, which is this side, and then 70 minus 10. Now that works out to be 100 divided by 60. Now if we go to a more standardized notation for speed, which is in kilometers per hour rather than minutes, 60 minutes in 1 hour. So the slope of P is 100 kilometers per hour. I mean, which is kind of like the speed notation you're familiar with in your usual life. Now if you go for Q, you see the y-axis remaining the same because it does travel 100 kilometers. Your x-axis is different. It's from 0 to 80. 0 to 80. So if I go down, q is still 100 kilometers, travels at 100 kilometers. Maybe I just use a darker shade. While this is 80 minus 0. Now what is 80 in terms of, what is 80 in terms of hours? 80 minutes in terms of hours. 80 minutes is 80 divided by 60 hours, okay? So it's basically 100 divided by 80 divided by 60, which works out to be something close to 75 kilometers per hour. It works out to be 75 kilometers per hour. So as we saw that, we looked at the slopes and we realized that yes, p is steeper than q, and so the velocity or the speed of p must be greater than q. This is what we actually work out. So we saw that the speed of p is actually 100 kilometers per hour, while the speed of q is 75 kilometers per hour. So everything makes sense. Now remember that, whenever you have this kind of a straight line and a slope, it's like the slope. The slope over here, what I want to say is that if you take p for example again, the slope over here in this small portion and over here is the same. The steepness of that line is the same, so we can say that it is at constant speed or constant velocity. Now what if the problem is slightly more different? It's slightly more difficult. So what if we are faced with a diagram which looks like this is your distance. Now we don't really need to go into the details of the distance, and this is your time. So what if you have a really complicated looking diagram where you don't have any straight line? So suppose you have something like this. Now this is not a straight line, this is something which is curving upward. What can you say about this? Is the speed increasing or the speed decreasing? So what you do is you start looking at the slopes of small intervals. As you see the slope at different time, the slope, say, let's say 1, 2, 3, 4. Let's call this the slope 1, slope 2, slope 3, and slope 4. You can clearly see that the slope 4 is the greatest, and it kind of decreases in this direction. So you start with a small slope and the slope gets steeper and steeper. What it really means is that you start with small velocity and you end up with a higher velocity. So the object which has been described by this clearly changes its velocity from a small velocity to a higher velocity during the time t, and in other words you call it acceleration. Now you really cannot say if it's constant acceleration or not, but we can definitely say that the body is accelerating, so it's increasing its velocity. So it's pretty similar if you have something which is something like that, distance versus time, right? So now if you again look at slopes, it starts with a high slope, slope gets less, and then it flattens out. The slope is like 0 over here, so it's high slope, low slope, and 0 slope. So basically what this body is doing is decelerating. Maybe my spelling is wrong, but decelerating means that my velocity is going down. So basically, in other words, in real life you call it slowing. Again, we cannot say if it's a constant deceleration or not, but from the graph, by interpreting the slope at different portions, you can really say a lot about it, if it's decelerating or it's accelerating, when you're not faced with a graph which gives you like a straight line. Okay, when it's straight line, it's quite easy, it's at constant velocity, but when you have all these curved things, it gets a little bit complicated. So I believe this video would let you understand the position versus time graph really well, and about finding out the slopes and basically interpreting the slope, how it's accelerating or decelerating. In the next video I'll be touching on the velocity versus time graph and what we can